In this video, students will learn how to set up the CE600 rectification column for total reflux, batch distillation, and continuous distillation. The unit will be used to separate a mixture of ethanol and water, which is done by exploiting the differing volatilities of the two components. The more volatile component, ethanol, should be in greater concentrations near the top of the column, while the less volatile component, water, will primarily remain in the reboiler or bottoms. This experiment will require typical lab PPE, such as safety glasses and gloves. Non-denatured anhydrous ethanol will be used in this lab. Be sure to review the labeling on its container and a safety data sheet. The distillation column and liquid samples will be hot. Be careful not to touch the column or any container used to collect samples with your bare hands. Heat insulating gloves are kept near the apparatus if students wish to use them. To operate the GUNT CE 600 continuous rectification column, students will need to familiarize themselves with the following components of the unit: the control panel, the reboiler, the condenser, the reflux tank, the distillate tank, the feed tanks, and the column itself. At the beginning of a lab session, the distillation column will need to be reset. An icon should be flashing at the bottom of the control panel screen. When touched, an error list will be shown. Any row with a 1 in it represents an active error, which will prevent the unit from operating. 2 active errors are expected before a reset: emergency stop and min flow. If other active errors are present, please notify the TA or instructor. To resolve the emergency stop error, simply pull the emergency stop button below the screen. The list will now indicate a value of 0 for emergency stop. The min flow error will be resolved later. Next, check the fill gauge mounted to the front of the reboiler. If any liquid is present in the gauge, it means the tank still has liquid inside, which must be drained before continuing. Below the reboiler, find the plastic tube connected to a valve labeled V22. Feed the open end of the tube into an empty waste container. Be sure to have a second waste container nearby, since one will not be enough to empty the reboiler. Open valve V20 by turning it counterclockwise. Then, open valve V21. When ready, open valve V22 to begin draining the reboiler. When it's time for a new waste container, close valve V22, switch containers, then reopen the valve. This will help avoid spills. Once the tank has emptied, close valves V22, V21, and V20. The last thing that needs to be checked is back over on the control panel. If this box in the lower right corner of the screen reads Guest, students will have to log in as an operator. Touching on the same box will bring you to this menu. Under User Administration, tap the left middle icon, then click on User. Enter the name Operator with a capital O and press Return. Then, tap on Password and enter 123. Hit Return, then hit Return again. The box in the lower right corner will now read Operator. 8 liters of a 20% by volume ethanol solution will need to be prepared. While in the fume hood, pour out 1.6 liters of anhydrous ethanol into a large graduated cylinder. Using a hex key, open the cap of the reboiler and then set it aside. With a funnel, pour the 1.6 liters of ethanol into the reboiler. Do this step slowly to avoid spilling alcohol. Measure out a total of 6.4 liters of DI water, then add it to the reboiler using the funnel. The fill gauge at the front of the reboiler should now be reading between 8 liters and 7 liters. Screw the cap of the reboiler back on, and tighten it with the hex key before continuing. The min flow error can be resolved by turning on the condenser's cooling loop. On the left side of the screen, click the icon with the snowflake on it. Under Manipulating Variables, click W3. If it isn't already set to 50%, do so, then hit Return. Tap the boxes within the flowchart labeled W3 and P3. This will initiate the cooling loop and resolve the min flow error. To set the reboiler temperature, tap on the button below the Home icon on the left side of the screen. Under TIRC19, make sure that the Auto and TiO3 buttons are selected. Regardless of the desired operating temperature for the experiment, students will have to initially set the reboiler to 85 degrees Celsius. The unit tends to overshoot the target temperature when starting up, and this initial setting prevents the contents from getting too hot. To avoid losing any water or ethanol while the column is heating up, we need to set the reflux to 100%. Make sure that under TIRC20, the hand icon and TI10 is selected. Tap on the number, enter 100%, and hit Return. It may take up to 30 minutes for the column's temperature to stabilize. Tapping on the button on the upper right corner of the screen will bring up a chart showing the temperature of sections of the column over time. This chart could be useful for determining when steady state has been reached. Now that the temperature in the column has stabilized, tap on the number under TIRC19 and change the setting to the desired operating temperature. When the column reaches steady state again, the temperatures for probes TiO3 to Ti12 need to be recorded. The recommended method for recording data is to take a picture of the screen with a smart device. The reflux drum should begin to fill with a solution which has a high concentration of ethanol. At a certain fill level, the contents of the drum will be siphoned off and returned to the column, putting the system into a state of total reflux. To collect the sample from the reflux drum, find the plastic tube hanging from valve VO3 and feed it into a container. Open the valve, collect a small volume of the solution, then close the valve again. Send this sample and any future samples to the group member in charge of operating the refractometer. Now, a sample from the reboiler needs to be taken. After feeding the plastic tube hanging from valve V22 into a container, turn valve V20 counterclockwise by a few revolutions. Then open valve V22. Once a small volume of sample is collected, shut both valves, starting with V22. To take a sample from a tray, first find the adapter tube located near the hex wrenches. Feed the open end of the tube into a container, then press the adapter end into one of the 3 ports until a click is heard. After collecting a small sample, push the metal sleeve around the port towards the column, which will release the adapter hose. To set up for a batch distillation, the percentage under TIRC20 needs to be changed to something other than 100%. Doing this will allow part of the top product to be collected in the distillate tank instead of being fed back into the column as reflux. During analysis, a variable named the reflux ratio will be important for calculations. The percentage you enter under TIRC20 is not the reflux ratio, but it is instead the reflux percentage. The percentage of the top product re-entering the column as reflux. An equation for converting the reflux percentage to the reflux ratio is shown here. After setting the reflux percentage to the desired value, use a stopwatch or smart device to keep track of how long the experiment has been running. At set intervals of time, a sample from the distillate tank is taken by completely emptying the contents of the tank into a container. To do this, open valve VO6 while holding the container under the spigot. Make sure to label each sample. Instead of batch distillation, students can choose to do a continuous distillation experiment instead. An additional 8 liters of 20% ethanol solution will need to be made for this option. Prepare the solution in separate 4-liter batches. Under the right feed tank, make sure that valves V10 and V11 are closed. Twist open the cap at the top of the tank, then, using a funnel, carefully pour 4 liters of the ethanol solution into the tank. Place the cap back onto the top of the tank, but do not screw it back in. After checking if valves V13 and V12 are closed, unscrew the top of the left feed tank. Fill the tank with the other 4 liters of ethanol solution. Then, like before, place the cap back on top of the tank without screwing it in. The volumetric flow rate of pump P1 will need to be calibrated. Make sure that valves V53 and V55 are pointed toward the user, and that valve V14 is open. After all valves are checked, open valve V11 on the underside of the right feed tank. Find the plastic tube connected near valve V55 and feed it into a graduated cylinder. On the control panel, tap the third button down on the left of the screen. Under Manipulating Variables, tap the number next to P1 and enter 25%. Assuming all preparations have been made, press the P1 icon in the middle of the process flow diagram. Pump P1 should begin turning, and the contents of the right feed tank will begin to flow towards the graduated cylinder set up earlier. Once any air has been pushed out of the tube, use the cylinder and a stopwatch to determine the experimental volumetric flow. Have a group member stationed at the control panel so they can shut off the pump when the calibration trial has concluded. 2 graduated cylinders will be needed to collect and measure the continuous flow from the distillate product and the bottoms product. The distillate will be collected from the plastic tube hanging from the reflux tank, while the bottoms are collected from the tube that was used to drain the reboiler. Find the plastic tube connected near valve V55 and plug it into the open end of the tray 5 feed port. Check if valve V11 is open, then turn on pump P1 to begin a continuous feed into the column. Crack open valve V03 slightly and adjust it until you obtain the desired distillate flow rate, which should be dropwise. The bottoms product flow can be controlled with valves V20, V21, and V22. To collect a smaller flow rate, crack open V22 like what was done with the distillate, while having V20 and V21 open. If the feed tank in use begins to run low, you can quickly switch to the other tank by closing valve V11, then immediately opening valve V13. Once you are finished with the experiment, shut down pump P1 and reset the manipulating variables entry to 0. Disconnect the feed line from the column and make sure to close any valves left open for the continuous distillation process. To shut down the column for the day, start by changing the reboiler temperature setting to 0 degrees Celsius. Next, turn off the cooling loop and reset W3 to 0%. Finally, press the emergency stop button below the screen.